also perform antibody screening and antibody identification. We do other tests, but these are the three most important tests we do over here. As you are all aware, everybody has a blood group, and blood groups are antigens that are inherited from our parents. So if your parent is blood group, one of your parents is blood group A, the other is blood group B, and you inherit blood group A and blood group B antigens. You are going to be blood group A, right? So these antigens are settled, and they are inherited through parental genes. So a chromosome will carry one, an allele will carry one gene, another allele will carry the other genes, and they come together to form the chromosome. That will give birth to your individual antigens. Now these antigens are encoded or found on the red blood cells at this moment. So in our, when we are performing the test, we use red blood cells to perform the test. We type or we treat red blood cells against known antisera that will detect a particular blood group antigen on the surface of the red blood cells. Now these are the various antisera you can find in any standard blood banking laboratory. Okay. I'm not going to go into the details of this one, but essentially there are four major blood groups using a particular blood group system. So you can have blood group A, blood group B, blood group O, and blood group B. Alright. When the negatives comes in, then we expand it to 8 specific blood groups. So you can have blood group A, B, A positive, A negative, B positive, B negative, O positive, O negative, AB positive, and AB negative. Right. Now, there are other blood group systems which you may not be familiar with. I won't bore you into the details. These are the two major blood group systems. Two major antigens we screen for routinely in the blood bank, the standard blood bank laboratory. Now, in 1901, a gentleman called Einstein, he's a physician, or he was a physician. He came up with these blood group systems. Now, in the beginning or in the olden days, transfusion was being practiced. However, transfusion was causing a lot of harm down the road. Now, before the discovery of blood group antigens, ABO, ABFO, people were being transfused regardless of their blood group. So there was no particular consideration to patient blood group to blood donor. So they just take a blood sample from what's your name? Vanessa. So they take Vanessa's blood. Enyonam means so they take Vanessa's blood and they give it to Vanessa. Hey, Enyonam. Now they have not determined the blood group of Vanessa or Enyonam. They just collect Vanessa's blood and give it to Enyonam. Now Enyonam may be compatible with Vanessa. Alright. That means that that particular transfusion will be successful. Now, when Vanessa is not available, then what's your name? Scott. They collect Scott's blood to give to Enyonam. Enyonam may have serious complications. Now, this gentleman can sit down and then realize that he needs to do something about this situation. People are dying unnecessarily. People are having serious complications. So what he did was that he called his co-workers and then sampled them, took their blood samples, and then separated them into red cells and plasma. He began to treat various individuals with various serum or sera, and then he discovered that the individuals had different blood groups, or they reacted differently to the plasma he was treating the red cells. That is when the discovery of ABO, antigen scale to be in 1941. So he labeled the first group that reacted to the plasma as A. The second group, he labeled them as B. The third group, he labeled them as C. The fourth group, he labeled them as D. However, as technology improves and we advance in studies, nomenclature changed and they maintained the A and B antigens. But blood group C became blood group O, blood group G became blood group A because of the molecular structure. Should an eligible candidate. Eligible in the sense that the person should not be coming from a high risk group. Now, when we say high risk group, high risk groups are classified as individuals coming from communities where, or who are involved in certain kind of lifestyles, smoking, use of drugs, other harm drugs. Well, I don't mention the rest, but particularly smoking, multiple piercing. You know, when people come from a particular, have conducted themselves in a particular way, you perceive they will not be eligible. You don't insult them, just go and use nice ways to disqualify them. Now, tattoos are very should I say, likely sources of people contracting infections. I don't know how they sterilize their patients, but people who have multiple tattoos are likely to have certain infections or are exposed to certain infections. So when you see people with multiple tattoos, you try as much as possible to eliminate them. Alright, notwithstanding, not all persons with tattoos are sorry to say, having infections. Alright, so sometimes you have to engage them to know why you get that in the particular tattoo they get. So, like when you engage them, you get to know that they appear to be in a high risk group, but they will not necessarily be that category. Right? So when you engage them and you deem them eligible for donation, you collect the blood in a particular bag. So the blood bag should contain an anticoagulant called a CPDA. When you are using any anticoagulant, any other anticoagulant, you must know the duration and the historic conditions to which the blood must be kept in order to ensure safety. Now the blood bag we use here contains CPDA. C is citrate, P is phosphate, and D is dextrose. A is adenine, CPD. Alright. Now this blood bag, with the anticoagulant is able to carry or keep the blood for as much as 35 days. After 35 days, the blood is useless, it cannot be used again. On the 35th day at midnight, that is when the expiry date has reached. Alright. Now, when you collect blood in the particular right kind of anticoagulant, right, and you leave the blood at room temperature, that blood after 24 hours is useless, cannot be used again. If you leave it on the bench like this after collecting it for 24 hours, it's useless. Because now this blood bag is semi-permeable. The bag allows gaseous exchange between the cells and the environment. There should not be so much exposure such that bacterial growth will occur in the blood. If you treat the blood this way, your chances of growing bacteria in the blood bag is very high because the blood is very rich in nutrients and microorganisms enjoy it very much. You keep the blood at any receptions. With the exception of platelet concentrate, where you have to keep the blood at room temperature. If you are going to prepare platelet concentrate, blood must be kept at room temperature. Because platelet concentrates, when you put them at and in fluid conditions, the platelets will no longer be viable for use. But if you keep them at room temperature, you have viable platelets for use. That will give you the therapeutic effect you desire. However, for fresh frozen plasma, if you keep them too long at room temperature, you may lose your clotting factors. In FFPs and cardiac resuscitators, we're interested in clotting factors. Factor 8 is the most volatile clotting factor, which has a shelf life of between 6 to 8 hours. After 8 hours of collection, if the blood has not been prepared into fresh frozen plasma, don't use it. You don't use it because factor 8 will be normal. And without factor 8, it ceases to be fresh frozen plasma. What can you observe between them? So this is the one, this is number 1, this is number 2. What can you say about number 1 and number 2? Come again. Okay, good. Now, when you collect the blood from the fridge, the first thing you should check is the plasma. So the plasma is 1, cloudy. 2, looks immolized. 3, it's too turbid. It should prompt you that there's something occurring in this particular blood. Now, this is a very clear plasma. This is a very clear plasma. Has a normal amber color. Right? So obviously, this is a safe blood. Per observation, not testing. By visualization, this is a safe blood. But this one is this plasma looks a little bit deeper than this one. So this should prompt you that there is some hemolysis occurring in this particular unit. So this particular unit may not be safe to transfuse. That's the first observation you can make. Aside that, if the blood stays out of the fridge beyond the temperature requirement, whether the plasma is clear or not, it is not safe.
I'm Ms. Babanana Asafo Abensa, a level 100 student of the Accra School of Hygiene, offering BSc in Environmental Health and Sanitation. So today, my class and I decided to come on a little educational trip to the National Blood Bank at Korle Bu, and we learned a lot of things, like blood being a vital part of the healthcare system. And we also went to other laboratories like the immunohematology lab, the microbiology lab, and the component processing laboratory. And in the microbiology lab, where processing of the TTI infections are done, like the hepatitis A, B, C, syphilis, and HIV. And at the end of all, we learned that blood is a vital part in healthcare. So we encourage everyone out there, be a donor and save a life. Thank you.